So, as I said at the beginning, this is a pretty good movie, science-wise, but I am going to find some bad things to say about it, because what would be the point if I didn't, really? So, we're going to talk a lot about Mars. This is, as you know, not exactly what I work on, but I am an astrophysicist. I work at the University of Texas at Austin. For those who haven't been to one of these before, welcome. To those who have, some of these rants may sound familiar. Now, as I said, I am an astrophysicist, so I am going to stick really to the physics, because there is so much science in here, we could be here until 1 o'clock in the morning, and I would be very happy to do that, but they don't give me the theatre for that long. So, we're just going to talk about the physics and the astronomy, and let some of the other stuff go. I have heard that there are some issues with the whole potato growing thing, but since I can't even keep a cactus alive, I'm going to leave that to the botanists. We're just going to talk about Mars. So, help if I switch this on, wouldn't it? Hey, Mars. Woo! Mars is a real planet. There you go. Are you happy? It is the 4th planet out from the Sun. That makes it one further out from us. It's not quite our closest neighbour. Venus is closer, or it can get closer. But Venus has a runaway greenhouse effect, making it extremely inhospitable, even more inhospitable than we saw Mars was in this movie. So Mars is the most likely candidate in the solar system for a planet that we might send crewed, not manned. The official NASA term is crewed missions to. And maybe one day colonize. So let's dive into the movie. This is right at the beginning of the movie. We're introduced to this place called Sedalia Position, which is where most of the movie takes place. This is the Ares 3 landing site. Sedalia Position is a real place. Here's a real photograph of it. This is from the Mars Reconnaissance Orbiter. So this is what it really looks like. It's a real place. This was actually taken 2 years ago today, on May 17th, 2015. Now let's zoom out and see a map of the whole of Mars. This is from National Geographic. You won't be able to read the labels on the resolution of PowerPoint, so I'm going to point some things out to you. Sedalia Position, the Ares 3 landing site, is way up here. Mars Pathfinder featured pretty prominently in this movie. That's a real thing. Landed on Mars in 1997, right about there. The other place we hear about is the Schiaparelli crater. This is where the Ares 4 mission is supposed to take place, so it's where the MAV is that Mark Watney uses to get off the planet, and that's over here. So you can imagine this is a projection similar to those you're used to seeing of Earth. Mars is about half the size of Earth, so you can kind of eyeball that's a really long way. He went a long way in that rover. If you've read the book, which I recommend, it goes into an awful lot more detail about the actual journey process, which was kind of skipped over in the movie. So this map, as I said, is from National Geographic. I found it in approximately 10 seconds on Google, which made this scene a little odd. I mean, you kind of have to imagine that if NASA has an active Mars landing program, that they have some maps on hand that are more convenient than the framed pictures in the cafeteria, right? But whatever, it's a nice dramatic scene. The other thing we're introduced to right at the beginning, through the labeling there, is that we are starting on Sol 18. So in case you didn't get this from context of the movie, Sol is a day on Mars. We know how a day is defined on Earth. It's the rotation of the Earth around its own axis. So this is Mars. Picture of Mars rotating just because it exists and it's cool. This is a real picture. This is taken by the Hubble Space Telescope when Mars was at its closest approach to Earth, which is pretty cool. So Mars is a little bit slower to rotate than the Earth is. It takes about 39 minutes longer. So the day is 24 hours and 39 minutes long. So one Sol is 24 hours and 39 minutes. Now, true story, when Mars sent the Pathfinder, when NASA sent the Pathfinder to Mars, the staff who worked on it had to work on a Sol schedule. And it might not sound like a big deal, right? You get an extra 39 minutes in every day. Who doesn't want that? But think about how much daylight savings messes you up, and now imagine your day slipping by 39 minutes every single day. Now the Mars Pathfinder mission was only supposed to last 7 days. It lasted 85. By day 30, I'm told the staff were close to mutiny. NASA, of course, like a lot of science, is filled with the type of people who don't like to admit that they can't cope without sleep. Luckily, by the time the other rover missions came along, NASA had realized that even scientists are humans-ish. And so they paid a little bit more attention to this, were a little bit more careful about scheduling, and they managed to get people to work on Sol schedules for around 90 days before they had to give up and put them back on a normal Earth schedule. Now, of course, for astronauts, which we've never tested yet because no one has ever been to Mars, but it's expected that real astronauts living on Mars would be totally fine living on a Sol schedule because you're getting the correct day-night signals, so you probably wouldn't even notice. So far so good. Everything so far has been real, except for the map thing, maybe. So let's come to our first problem, and this is the thing that kicks off the plot in the movie. I do like how this movie gets right down to business, right? It doesn't mess around. It starts off right away with this dust storm. And now, a lot of what they did with the images of Mars is pretty good. Mars is red. It's red because there's a lot of iron near the surface, and iron oxide, you may know as rust, is red. It is very dusty. It is a bit of a desert planet, and dust storms do happen on it. This is a real animation of a real dust storm observed by the Curiosity rover in February of this year, just 3 months ago. So dust storms are real. However, there's a little bit of a complication with this little plot point, which is Mars has very, very little atmosphere. Mars's atmosphere is about 1% of the density of Earth's. This means there's very, very little atmospheric pressure. And so there's just not enough of an atmosphere to generate the kind of forces they're talking about. They talk about 8,600 newtons worth of force from this storm, enough to tip over the MAV. So this is a huge amount of force. There's no way you're getting that from this puny little atmosphere. So, to be fair, Andy Weir, who wrote the book, does acknowledge that this is a big flaw, probably the biggest scientific flaw in the story, but he needed it in order to strand Mark Watney on Mars. So I choose to take that as kind of reassuring that he couldn't think of a scientifically plausible reason someone would be stranded on Mars. But it just does give me an excuse to talk a little bit about why Mars doesn't have an atmosphere, and there's a couple reasons. First of all, as I mentioned, Mars is about half the size of Earth, and it's about 1/10 of the mass. So this means that there is much less gravity than there is here on Earth. So in fact, if you were on Mars, you would weigh about a third, actually 38% of what you weigh on Earth. So going to Mars, great way to diet. Well, this also means because there's less gravity, it's much harder for Mars to hold onto an atmosphere than it is for Earth. If there's little gravity, it's much easier to escape from the surface. You don't have to be going as fast as you do on Earth, and that counts for air as much as it does for humans. So the air can drift off far more easily than it can from Earth. That said, we don't think Mars was always like this. A planet the size of Mars should be able to hang on to more than 1% of the Earth's atmosphere. So this is where this guy comes in. This is MAVEN. It's an artist's conception, but it's a real satellite that's in orbit around Mars. Now in 2015, about 2 years ago, this satellite studies the atmosphere around Mars, and the scientists using it announced a really, really cool result, which is that it looks like Mars used to have an atmosphere, or a thicker atmosphere, that was stripped away. So another artist's conception, just because. This is what Mars may have looked like when the solar system was very young, nice and lush and wet, and a bit warmer than it is now. But when the sun was a lot younger than it is now, it was far more active, a lot more high energy radiation was coming off it, and Mars doesn't have the magnetic field that Earth does. Our magnetic field protects us a lot from the solar wind coming off the sun, Because Mars doesn't have this, the solar wind can strip the atmosphere right off and turn that nice watery planet into what we see now, a desert world. So another artist's conception just for fun. The image on the right is a pretty picture of what we think Mars may have looked like one day, but sadly now it looks like the image on the left. So this is what makes it inhospitable, which is what makes this a movie that requires a lot of science. However, I did allude to another thing that is a problem with pretty much every scene in this movie, including innocuous things like this one. I mentioned that the gravity is an awful lot lower on Mars than it is on Earth. Noticeably lower, at 38%. So this is what should have been happening. You should have been bouncing around, not quite as much as you saw the astronauts on the moon, but still, everything should have been noticeably lighter. And this was not apparent to me in the movie. I am told that there was some attempt made to film at a high frame rate and slow things down to give the appearance of low gravity, so that things were moving more slowly. I didn't see that. So I guess this was an artistic choice that it was too difficult to film. So unlike the previous movie we did, Gravity, this one really did not do a good job with the force of gravity. Near the beginning of the movie, Mark Watney tells us about all the ways that he's going to die. And most of them are fairly straightforward. If you run out of water, you die of thirst, yes. If you run out of food, you're going to starve to death. But he mentions that if the HAB is breached, that he will kind of implode. And this is a really common misconception that's not really true. A lot of science fiction likes to run with the idea that if you're exposed to a vacuum of space, you're going to like suddenly explode. That's probably not true. I mean, no one's tested it, but most likely you could probably survive for about a minute. So all the water will evaporate. There's not enough atmospheric pressure on Mars, so water boils at a very low temperature. That's not good. Our bodies are mostly water. Obviously, you can't breathe. Not only is there no oxygen, there's not enough atmospheric pressure to get anything into your lungs. So he's going to have a very, very bad day if the HAB breaches, as indeed it does. But luckily, duct tape fixes everything. That is real science. Another problem is that Mars is extremely cold a lot of the time. It actually fluctuates a lot. Its average temperature, -81 Fahrenheit, pretty chilly. But it fluctuates all the way from a nice balmy 86 all the way down to -284. So you might wonder, why is the range so much higher than Earth? You might expect it to be colder, of course it's further from the sun. But if you were at the gravity screening last month, you'll already know that the atmosphere affects an awful lot of how you feel temperature. It's not enough to receive energy from the sun. You need that heat to be transferred to you somehow by atmosphere. And there's no atmosphere. Another thing you might not be as familiar with because you live in Texas, but certainly when I was living in England, I was very aware that in the winter, the thing that controls the temperature the most is how cloudy it is. It's how much warmth you can retain in the atmosphere when you lose the energy from the sun. Mars's atmosphere being very thin is obviously not retaining much energy, so you get these wild fluctuations between pretty warm and extremely cold. This is a thing, of course, that showed up in the movie, in this scene. When he's trying to figure out how to heat his rover, it is extremely cold. You might question the wisdom of overcoming this using a decaying radioactive isotope, but he's Mark Watney. He can do what he wants. So, another really cool thing that we saw, like while he was driving around in his rover, lots of really cool Mars scenery. I forget where this was filmed, somewhere in the Middle East, but it looks really Martian, right? I really like how you get these really dramatic rock formations, which is what you would expect because you haven't got the atmosphere eroding things. Obviously the redness, the sky is red. It's not really the sky, it's that there's a lot of dust in the atmosphere which makes it look red. One thing they got wrong is you see a sunset at one point. The sunset on Mars would actually look blue, kind of counterintuitively, but whatever. The thing I really like in this scene is this guy over here. This is a moon. Mars actually has two moons, Phobos and Deimos. They are both extremely tiny. Phobos is around 13.8 miles across. Deimos is even tinier at 7.8 miles. These are very, very, very tiny, but Phobos is very close to Mars, so you should actually be able to see it in the sky. In the book, Mark Watney refers to Deimos rather as a little piece of crap that's no use to anybody. His words, not mine. So another really big part of this movie, apart from all the stuff that takes place on Mars, is the Hermes. And this is another thing that I think this movie does really well, is the actual mechanics of space travel. The Hermes itself is a little weird. It's pretty huge. Like, look at all that space they have. We saw they had this nice, well-equipped gym. They have this whole dining table area. This is serious first-class space travel. And I have a bit of a problem with this because putting stuff in space is really, really expensive and really, really hard. And for every kilogram you add to your spaceship, you're spending around another $100,000. So that is a lot of unnecessary kilograms in this spaceship. This is humongously expensive. I really want to know where NASA is getting its funding in this movie. However, its size apart, the way it works is pretty neat. We see that large parts of the ship are zero gravity. You see them floating around and having to maneuver themselves through tunnels. But then there's this section that's rotating where they have gravity. And this is because of the rotation. It's exactly the same force that causes all your laundry to be pushed out to the outside of your washing machine. The gravity here is really an acceleration. It's going to push you outwards. So down, from the astronaut's point of view, is going out from this circle. And I really like how they showed that. So you see that down is a different direction for different people at the same time. That's really, really neat. And this is probably the best way to create a kind of fake gravity in space and get over some of the problems that you would have if you're on this really, really long mission. One of the biggest problems is that your muscles are going to waste away because you don't have to exert any effort in zero gravity. So not only do they have gravity, but they have a gym so they can stay in shape so they can actually do stuff when they get to Mars and back home. Another problem they don't really address with long-distance space travel is cosmic rays. It's expected that if you're in space for that long, you'll probably die of cancer. Presumably, they figured this out by the time this movie happens. I hope so, because that would be really sad to go to all that effort, and then he gets back to Earth and dies of cancer. So this is another scene that I thought was really, well, not this scene, but this maneuver was done really, really well. This is the gravity assist, where they get the Hermes to whip around the Earth and go back to Mars. This is a real thing. You really can use gravity assists. One of the things people ask the most about this movie is, why didn't the Hermes just turn right around and go back and pick him up? And this is because maneuvering in space is really hard. Every time you change speed or direction, you use fuel. There's a limited amount of fuel. So you can imagine the Hermes was presumably in orbit around Mars while they were all down on the planet. At some point, it had to leave Mars orbit. That means you have to speed up, and you have to go really, really, really fast to get all the way back to Earth. Now, all of the fuel that you use to accelerate to that speed, you're going to have to use the same amount of fuel to decelerate back to zero, and then the same amount again to accelerate to go back to Mars, and then even more fuel to slow down to enter Mars orbit. And suddenly you've got no fuel to go home. So this is extremely different to a Star Trek universe where you just hop around from planet to planet, enter standard orbit, beam up, beam down. This is a lot more realistic and a lot more tedious. But gravity assists and these kind of maneuvers and was going to say they're not rocket science. I guess they're technically rocket science. But to the director of NASA, I'm assuming the concept is fairly routine. Anyone who has read Arthur C. Clarke, the concept is fairly routine. So the idea of having to demonstrate it to the director of NASA with a stapler is a little weird. But it was an amusing scene, so I'll give it a pass. I really like Jeff Daniels' face there. I especially like that he knows who Glorfindel is. That made me very happy. Now they do kind of gloss over this, but they mention very briefly that it's a bad time to go to Mars. This is because Mars and the Earth have different lengths of a year, so it takes them different amounts of time to orbit around the Sun. The Martian year is almost double the Earth's. Obviously, the Earth doesn't really stop and wait for Mars to catch up. So this means that they can be at wildly different positions in their orbits at any one time. You could have them nicely lined up like that. That's what you want if you're going to Mars. Actually, you want it slightly behind, because if you're going to Mars, you don't point at Mars, you point at where Mars is going to be in 6 months or however long it's taking you to get there. You definitely do not want Mars to be way over the other side of the Sun. This diagram is not remotely to scale. They are much further apart than that. Because of the situation in this movie, they don't get to choose their launch window. So it is non-optimal. Now, because I've praised a lot of the space travel in this movie, obviously, I have to talk about this scene. I mean, I don't know what to say about it. So if you were at Gravity last month, you will remember that I took issue with the scene where she flies around space using a fire extinguisher like Wall-E. This is so much worse. Because not only does he realistically have no control over that, he's also cut a hole in his spacesuit that's keeping him alive. So there are so many ways this can go wrong. But as someone just pointed out, this does not happen in the book. What happens in the book, I'm going to spoil it, you just saw the movie, you know how it ends. He suggests that he's going to cut a hole in his suit and fly around like Iron Man, and Commander Lewis comes back, no, that is a terrible idea, which is the correct answer. But you know, movies. So one last thing that I have to mention, most normal people probably didn't notice this, but if you work in computers, or if you're an astrophysicist, this was the scene that caused the most conversation after this movie came out. Where Rich Purnell has to check his calculations on NASA's supercomputer, so he goes to the supercomputer and plugs into it, runs some kind of code that takes long enough that he appears to kind of fall asleep, and it then flashes up with a message, calculations correct. So we use supercomputers all the time. We actually have a supercomputer here in Texas called the Texas Advanced Computing Center. I have 5 codes running on it right now as I'm speaking. I am not sat next to a supercomputer plugged into it. I submitted a batch script like a normal person. I don't even know where the computer physically is. I've never seen it. No one does that. You either log in with a terminal or a virtual desktop or something. So this was weird. However, everyone I know after seeing this movie said, hey, I'm going to write a line in my codes to flash up a message saying calculations correct. So overall, I have to say, this was a really, really good movie, both entertainment-wise and science-wise. And although I've picked a few holes in it, on the whole, I think it was pretty amazing, and they did a really good job at accurately portraying what space travel might be like, and how someone might solve problems when it all goes wrong. And really, I think the biggest problem I have with it, the thing that's the most unrealistic, is how much taxpayers' money was spent to save one person. And I'd like to think this is a realistic portrayal of the future, and that someday NASA will have that money, people will care that much about science and space travel, and maybe if we're spending that much money to save one person, maybe universal healthcare isn't that difficult. However, even if this happened in real life, I challenge you to get that many British people that enthusiastic about anything. Okay, so that is my scientific summary of the movie The Martian. I do recommend reading the book if you haven't already, although I will warn you that Mark Watney is even more obnoxious and a bit of a misogynist in it. So if you come back next month, we have a very, very special event. The American Astronomical Society has 2 meetings every year, a summer meeting and a winter meeting, and this year they decided to torture the American astronomical community by bringing them to Texas in the summer. So we're going to have a huge influx of scientists right here in Austin, and I am commandeering some of them to come here and show you guys a movie. We have me, obviously. Those of you who have been going to Astronomy on Tap for a while may remember MC Super Duper Nova, Dr. Jeffrey Silverman. He is coming back from California just for 1 week. We also have Dr. Ashley Pagnotta, who is an astrophysicist at the American Museum of Natural History, where she works just down the hallway from Neil deGrasse Tyson. And Moya McTeer is an astrophysicist and science writer from Columbia University. Those of you who were at Astronomy on Tap last night may have seen that we announced the title of the movie. I found out while I was driving here that there may be an issue getting the rights to it, but I can tell you it is going to be a science fiction comedy, because I've done enough serious science movies. And it's going to be a lot of fun. It will be 8 p.m. on Wednesday, June 7th, yes. Right back here at the Alamo Drafthouse Mueller. Tickets should be on sale on Monday, so look out, you'll find out what movie it is, and so will I. So I want to thank the Alamo Drafthouse very much for hosting us tonight. Thank you to Max for emceeing for us.
You're welcome.
To Lara for filming this for the people who couldn't be here because you sold out the theatre. And thank you all very, very much for coming. I don't get paid to do this, but the Alamo Drafthouse gives me this stage because you keep selling out theatres for me. So thank you very, very much for continuing to allow me to do this, and have a great night.